All right, hello everyone. So glad you are joining us today for the second session of our What's New in Solid Edge ST8 series, Pattern by Table. My name is Diana Dietrich. I'm the marketing specialist here at Swish Technologies, and I will be your moderator for this session. Just a little bit about Swish. We've been a leading provider and partner of Siemens PLM software for over 10 years, headquartered in St. Louis, Missouri. Our team is dedicated in providing companies like yours the best training, support, and software, including NX, Teamcenter, and Solid Edge, necessary to accelerate productivity in your processes. Also, we pride ourselves in delivering process-based training solutions tailored to fit your company's needs. With our educational training services, our goal is to make you a leader in your field while staying ahead of your competition. Presenting today is application engineer Dale Duell. Just a little on Dale. Dale is a certified Solid Edge professional and trainer. He has supported, trained, and demonstrated Solid Edge to more than 1,500 students across America and is the author of several custom Solid Edge manuals that are used globally. Our agenda for the day is on Pattern by Table. Following a brief history of the topic, Dale will be providing a demonstration within Solid Edge ST8. We will then end with Q&A, so if you have any questions, please don't hesitate to add these into the questions box located in your GoToWebinar control panel. Dale will have your questions answered following the demonstration. All right, take it away, Dale.
Great. Hey, good afternoon, folks. Let's go ahead and get started with this, with our agenda today real quickly. Before we do pattern by table, we're going to back up just a little bit and kind of fill out this session with the idea of recognized pattern. It's been improved in ST8, but actually it's been around for just a few revisions or a few versions earlier. But we're going to do recognized pattern and then pattern by table. Now, the interesting thing about pattern by table is that it's user-defined placement, so it's not necessarily 3 by 3. Excuse me, the computer. But it's not like 3 by 3 or 12 in a circle or something like that. Yeah, it's very specific placement of parts that you want, and you're going to control where you want that pattern to be. So it can be just as irregular as you want it to be. They also have specific orientation. So one can be at 90 degrees, one can be at 45, one can be at 82. They can just be anywhere they need to be as you place this along, and I'll show you how that works. And also what this does is allow it to be a repeatable master layout for the project, and you'll see that. So let's say you've got multiple pieces that are going to stack on top of each other, a bottom of something, a bunch of internal electronics, and then the outside casing. All of those components will have the holes that are related to this master sheet. And that way, you know, change the sheet, we're going to change everything at once. You'll like it. I'm just positive of it. So let's go ahead and get started with this. Well, the first thing I want to do is talk about recognized pattern and just kind of warm up to this idea that we have out here on recognized pattern. And just go ahead and open this part, just this simple little part standing out here, and this illustrates what we're going to do very well. You notice this part does not have any features over in the Pathfinder. We got a little part copy. It does happen to be synchronous, but there's nothing else, right? This just could come from anywhere. And I just want to show you how fun this is to work with. So I'm just going to take this face right up here and just kind of drag this face up. I just need some room. This is going to be the side of a panel. Of course, you can measure it. You can do anything you like. I just need some material, if you will, to work with. Now, I want you to see this. As I drag this out, my design intent, if you didn't see the last session that was done, but my design intent is going out on symmetric, right? So my design intent is symmetric. I want to uncheck that symmetry, if you will, and then just pull this over a little bit more. See, I don't want that to go both ways. I want that feature to rest there in the corner. Now, a couple things I want to do with this just to kind of set this up, and we'll have some fun. I'm just going to window this, take my handle, sort of orient it, and I want to copy and you'll see where I'm going with this just real quickly. I want to copy this and then just bring this up here somewhere. It doesn't really matter where that it goes. And take something like that. Do the same thing. Take this over here and bring this over, and just we're playing. Yeah, you could mirror this, you could do a bunch of stuff, but just as easy as not to say, I need some vents. This is a machine panel, and we obviously care a little bit about decoration, so we're going to make this little sunflower, sunrise thingy, whatever we want to call it. So I've got this setting out there. Now, obviously, I'm thinking pattern, right? I've got a 2x2 pattern, and I've got a bunch of circular patterns around. So what I want to do is just zoom in here, and the first thing I'll do is start talking about is this recognize patterns. First thing I want to do is I just want to highlight the master occurrence, and that can be any one of them, but I'm just sort of saying the 12 o'clock position there is the master occurrence. Just it's easier to figure out. When I do, I'll simply go out and say recognize pattern, and as I do, Solid Edge is going to go find two of those patterns. It's going to go find the circular, and it's going to go find the rectangular. So if without the master occurrence on the sunflower circle there, it wouldn't have found the circular. So I had to do that. But then once it saw that, it says, hey, you know what? These features are all the way around here anyway. I think they're all the same. And of course they are, and that's what we're thinking. So just by saying okay, we're going to now put two patterns over here in our Pathfinder. One is the circular pattern, and one is the rectangular pattern. Solid Edge has already found that for us. So working with the circular pattern, let's say we had 12 and I want 15, and since I have 15, that's a little crowded, so we'll probably pop that up to 7 and see what it does. A little too much. Okay, we'll kind of take that back. We might not move those at all. Might just leave it right where it is at. Let's say 6. We'll see what happens. There we go. We got 6. We got a little bit of a twist there, but that's okay. So we've got these parts. Actually, it looks just a little bit better than it did before. So we've got these parts sitting out there in this pattern. The pattern, it understands that we wanted 6 or 12 or 5 or whatever. And then the rectangular pattern now takes hold, and we can edit that just as just the same as if we would have designed it ourselves, and just work with it right like that. Okay, so just to back up on this, again, Solid Edge is closing those gaps between who made what. And in this case, we don't care who made this pattern. We don't care who made this pattern. The point of it is completely editable. And once this part comes into my Solid Edge, this is my part, I can do what I want to with. Okay? So we'll look at that, and then let's go out and start to work with our pattern by table. So we'll go ahead and look at this just real quickly. Here we go. So I've got a sheet, just a piece of sheet, and I've got a opening here. It's going to have an indicator bulb for some sort of control panel. And you notice that I've on purposely left it off of the coordinate system, and I'll explain that to you just in a second. Now, to that function there, to that sheet, I've already got a sketch, and just to save time, we made a sketch. Now, you'll see that this line here, this y-axis that's coming down, you'll see that I've got it locked, and it's at an endpoint. Okay, so this is sort of the center of, or the origin, if you will, of my pattern, and everything is taken off of this. So all of these lines right here will be the center of this opening. Now, we don't really care if they're If they're driving or driven, all I need to know is where is that exact point. For instance, that exact point is 2 in the x and 2 in the x and 2 in the y. Yeah, I mean, that's all we really care about is where is that part, or where is that point right there. 2 in the x, 2 in the y. And as we come around, if you kind of dust off our geometry, even though this is 2.5, 2.5, this will be positive in the x, 2.5, and this will be negative in the y. So this will be negative 2.5. All right? So we're using that type of work. Now, to that, we've created a spreadsheet. We'll pop this up right here. We've created a spreadsheet that captures all of these coordinates. So this first one, 0, okay? The first one is 0 by 3. See that? 2 by 2, 2.5, negative 2.5, and all the way around. So the first 3 columns here are x, y, and angle. Okay, not z, but angle. So the first one is going to be 0 degrees, 45, 90, 22, 90. So that's the clocking, if you will, of how I want these to go around. And these could go anyway. They could all be 0, they could all be 90, they could all be 45. It doesn't matter. It just only matters what your design is. So the first 3 rows, when I create this, you know, I want to fill these in. And I don't want to put anything on here other than the coordinates, so x, y, and z. And I prefer to have my master one up top. There we go. So we see that the 0, 3, and the 0 degree angle. After that, over here you can put some things if you want, like this is clockwise 1, 2, 3, 4, 5. If I get them wrong, that's fine. It doesn't matter. It'll become obvious, but you can put anything you want to over here. Just please leave these columns, these 3 columns here, reserved for your x, y, and z. Okay? So just a little build up on that. Now that spreadsheet now becomes the master layout for, you know, other pieces. You know, since this is electronic, you know, maybe the motherboard behind it, or the switches, or anything else that you want. That becomes the master layout for this part. So, you know, other parts can use this in an assembly. So what I want to do is just take this first occurrence, just like we're doing already, and I want to just come over to my pattern, and I'm going to say pattern by table. And what it's asking for is a coordinate system. Now, the reason why I purposely left it off of this coordinate system is because, yeah, you could put a pattern around this sketch around a coordinate system. But multiple sketches, multiple places over the panel, they're not going to have that coordinate system, you know, handy. So I'll just sort of back out of this. And so what I did at that point is just simply bring down a coordinate system, and, you know, just placed it at the end of my line there. See, it wants to snap. So I've already got one, but all I did was bring down a coordinate system. So I've got a, you know, if you will, a new center of my universe, right? That's the new center. You can always use the one that's here, but like I said, you got multiple places. You just need a good 0, 0, 0. You could put it here. I maybe could have put it here, and everything would have been positive in the x. Maybe I could have put it down here, all the way here, perhaps, and then most of it would have been positive in the y. You know, it could be anywhere that you want. So having done that, we'll just simply go back to the pattern by table, and we'll look at that, and then we'll identify the center of our coordinate system, where is 0. And then we'll go browse, and then we'll find that bulb replacement. And Solid Edge will take all of those placements that we have, 2 by 2, 45, 2.5, negative 2.5, 45. We'll put all of those right in the part, just as beautiful as you want to. Again, oh, you know, you can maybe put these around, but they wouldn't be a pattern. They would just be, you know, scattered here and there. You'd have to figure it all out. With this, all you've got to do is fill out that spreadsheet and tell the part to obey the spreadsheet. So I'm going to update, and we'll just say OK. and Solid Edge will go out and put those out there. So my pattern by table is setting out here. So just like any other pattern, once I have it, I click on it. I can go click on the pattern by table. I go back to my little sheet. I'll say I want to edit my sheet. This is kind of like curved by points, if you will. And I'm just going to move a few things around and just say this one here is 1 by 1, 1 in the X, 1 in the Y. We'll come over here and I'll say maybe this one is 2.5 in the positive, and we'll make this a negative 2.5. And it'll come around and say this one is going to be 45, just for the kick of it. This one's going to be 45, and we'll leave that one 90, okay, just so we can see the difference. I'm going to save my list, close it. I'm going to update my model, and we'll have my parts move right around. So you can have these at any way that you want. Now, a little bit later on, I think we're going to go clean that up, but the point of it is you can move these to any angle, any degree, any idea that you want. Now, I think I really will clean this up, and I'm going to go over and say most of you guys are, just copy this one and just bring it down. All of you are going to be at 0, you know, just like that, okay? So changing all that little Excel, my idea of Solid Edge and Microsoft is let Microsoft Office do what it does best, let Solid Edge do what it does best. They both work together. We really don't care where that information comes from. Don't care where that information comes from. Let the program do what it does best. And this goes out and puts that out there. So if I have that, we'll go update. Now, obviously, you see this sketch is kind of like, well, we don't, you know, it's not obeying the sketch. Well, that's right. It only needs the sketch once to lay that out. What is guiding it from that point on is the table. Okay, so we'll go save this model. And I want to show you the benefit of doing this rather than just kind of chucking holes in there time after time. So I've got my part new, and I'm going to go create an assembly of this model. I'm just going to bring that in. I'm going to kind of set it up like that. Okay, and I'm going to go bring in this indicator bulb. It's just you know, some sort of a control panel light that blinks. We'll do a little bit of quick pick. Just bring that around, and then we'll just take that back and put it right back there, okay? So just set it right like that. Just sort of set it in there somewhere. And here's the point. Now I can take this bulb, and if you've ever seen in my classes, this is the fun part. I'm going to go to this bulb, and I'm going to take this sheet, and I'm going to take this pattern. I'm going to tell it to start here. Once I get it there. It's going to start there and finish, and it's going to go in every occurrence. So twisted, 82, 85, 84, it doesn't matter. It's not just simply going around. That bulb is going to fill that spot. That spot is going to be based off of this spreadsheet. So simple as that. If you want to control it, you want to direct it, you want to drive it, it's right over here. It's going to give you what you want. Now, I'll move on just real quickly and just show you what else is, what other ideas is good for pattern by table. And let's go something a little more complex. So we'll go look at the back side of the saber saw. And all of these bosses are setting out there, and they've all been, we've used PMI to ordinate dimension it. So I've painted the red one here. I've painted that myself so you can see that. But you see the 0, 0. So once again, as we're going, you know, this would be 46, 90, whatever. This would be negative 832, you know, any way that we wanted this thing to go. depending on the coordinate system, but all of these are accounted for. Now they're accounted for, again, in this boss table, okay? So they're accounted for in that boss table, negative 832, 325, and I want you to see the X, Y, and the angle. Since that was the very first one, the X is 0, 0, right? I mean, that's where it's at. It's right in the center. And then the second thing is the angle. And why are these all 0? Well, because the bosses are round. They're, you know, you can spin them all you want, right? But they're going to be 0. They're, you know, that doesn't, you can tell the difference between 0 and 45 in a circular device there. Okay, so setting right there, giving us what we want. So now, let's go over and open the other part of this that has to go on there. And we'll go look at this front, and you'll see that it doesn't have any other bosses in it. Shoot, I don't want to put all those bosses in there. I don't know where they go. I don't know how they match. You know, how would I do that? Well, let's look at that real quickly and just see how we've done that. What we've done is taken this boss and the hole and made it a user-defined set. So when we pick one, we pick the other. Okay, so we're going to go look at picking that, and then come back up to our user or pattern by table, and I'm going to go identify the start of my orientation there, and then I'm going to go browse, and actually I want all of the parts, all of the bosses to sort of start right there in that center. Okay, so I'm going to go browse, and I'm going to take that boss table, and it's going to fill out that boss table, and you see those red dots already appearing, and you see the bosses already popping in. They're in the exact location that the other bosses are. So think about that. I mean, you know, how cool is this that I've got one part, one table that is controlling two parts? You know, we've asked for that for years. This is happening now out in pattern by table. So we'll just drive that out and let all of those bosses reform themselves back in. Of course, I'd be remiss if I didn't describe how beautiful it is that those bosses actually cut through those ribs and give you exactly what you want. So think about this. If I have electronics setting out here, I want to use the same orientation, so I've got some sort of motherboard here, and there'd be a hole in that motherboard, right? None of these others would count, but there'd be a hole in that motherboard. And should that spreadsheet change, not only am I changing the front half, the back half, but I'm changing anything in between, all the electronics in that. So it's very simple, very easy to digest, if you will. Just the idea of pattern, you know, recognizing patterns, you know, being able to say, here's the first instance of the pattern, and look at all this, and then it says, yes, these all seem to be in a circle, or these all seem to be in some sort of XY array, and it will go find all that. And then the other thing is the pattern by table, and using that master Excel sheet that is going to go drive multiple parts. All right, so this is kind of digestible, really quick and easy. That's what I have for now. I'm going to turn it over to Diana and just let her take it from there.
Thanks, Dale. So we have a few questions in the queue today. Our first one is, can I add or subtract occurrence from my pattern?
Oh, yes. Yes, you can. So let's go back and let's go over just here real quickly my recent documents. Let's go over my pattern by table part. Okay, so let's go look at that for a second and just crack that pattern by table. And we'll go crack the table, right? So I can set another one over here, and it doesn't matter what order it's in. So I'm going to set one here. Perhaps that's well. Let's go do that. Let's just add one right here. So perhaps in the X it's over at 4 in the, well, let's just say it's at, let's do this. It's at 0 in the X. In the Y, it's at a -4. And the orientation then is 45 degrees. Okay? Doesn't matter what I call it here. Save the file. Make sure that file's saved. Close the file. Okay? Update the part. I've got a part right down there. Same thing if I wanted to delete something, just take this one right here. And I'm going to be just safe. I'm going to delete that whole row. I don't know if you can have spaces in here or not, empty cells. I'm not going to risk it. I'm just going to save it and update it there and lose my parts, just like that. Okay? Oh, while I'm here, I want to go back out to my recent documents, and let me see where else I want to go with this. Where was I? I don't know if I saved that or not. You said pattern by table par. I didn't. But if I had, and which I didn't, with the assembly patterns, all of those indicator bulbs would follow in right in line with that. Okay, so that assembly pattern, is the last thing we have to worry about. Is everything in this assembly? That assembly pattern is going to follow this pattern. This pattern is following that spreadsheet. Okay. If that answered it, yeah. Next question.
All right. Our second question is this for synchronous only?
No, this actually works in ordered, just the same. Just so you can see this, I'll say new. I want a 1-inch part. I'm going to switch over to ordered, just so you can see that, and we'll go over to our pattern, and you can see pattern by table sitting right out there ready to go. Okay.
And then we have one final question in the queue. Can I do this in assembly?
No. The pattern by table is for the part. However, we do have 2 really nice things that are going to do that. One is capture fit. In other words, we care how certain parts are going in. But the other one is what came out last year in ST8, and that's called duplicate parts, or duplicate parts, if you will. And what that does, it just says everywhere, let's say everywhere this pipe is, so goes the valve. And it doesn't matter where it's at. It doesn't matter if it's in a pattern, in a 3x4 pattern, in a circular pattern. It just says everywhere you see this pipe, this raw pipe standing up, stick a valve on it. Everywhere you see this socket, put a light bulb in it. Everywhere you see this washer, put a nut and bolt on either side of it. So sort of a redundant type response, but the point of it is assembly has other features that pretty much does the same thing as this part does. Anything else?
All right, thanks so much. No, thanks so much, Dale. So unfortunately, we are out of time for the afternoon. However, we want to be sure that if you have any questions, or if questions do arise or anything about today's topic, you have the right contact to go to. So if you have questions relating to utilizing the program tool, please feel free to reach out to Dale by phone or by email. He's more than happy to help. Or please reach out to your Swish sales representative for further information. If you don't have a Swish sales representative, please feel free to reach out to me, Diana, and I will direct you to our sales manager here at Swish Technologies. Once again, thank you so much for attending Pattern by Table. We will be on hiatus next week, but we hope you can join us on Wednesday, September 30th at 2 p.m. Central Time for our third session in our series, Assembly Sub-Assembly Design. If you haven't registered, please be sure to do so in the email invitation that was sent out, or by going to the official series page, which Dale, if you go to the next slide for me. There we go. So that
Sure.
is the link on the bottom. If if you didn't get the email or anything, if you'd like to be added to our email email system and everything, just let us know and we will get you on there. All right. Thanks so much, everyone. Have a good day. Bye.